So there's this relationship between Python and then also Miniconda and HTML. So HTML, as I said before, is written in Python using the Python 3 syntax. Maybe, I don't know that if you know this, but there's some difference between the Python 2 and the Python 3 syntax, and some small differences, but it still matters. So sometimes the code is not portable between one and the other. So, and basically HTML is and works as a Python module. And the Miniconda that you see over there, that many of you, I don't know if you're familiar with it, Jenny already talked to you about the Conda distribution package. Basically, HTML, like ACEMD and other tools that we have, are distributed through a package / model distribution platform called Miniconda, which is a lightweight version of Anaconda. So this is basically a place on the web where you can just put packages. You can even do it yourself. You can create your own account and put your own packages and create your own channel for distributing your own software. So we have one channel for Acellera, and we distribute our software through there. So this is just a more management kind of thing. It's not important for you. It's something that you need to use if you're using HTML, because it's a way that you, if you want to install HTML, you use Conda. Okay? So the advantages of Miniconda, of using Miniconda, and why I think that it was the idea of using it in the first place also, is that it already distributes. So we have many operating systems, different settings, different things. So the advantage of Miniconda is that everything is a little bit self-contained. It already brings Python and interactive Python interpreters. It's already self-contained, so the modules are inside Conda. Okay, you install everything inside Conda. Everything is foundable inside the package, so inside all of this environment. And as such, you can also get rid of stuff and not messing with the rest of the operating system. So you don't really know where things are. It's okay. You can get rid of Conda, start a new fresh installation. It's fine. There's some other things that we may have some more tutorials also in the future, which is how to manage, for example, Conda environments, where you can have different environments with different versions of HTML, of some software, install specific one in one environment and not in the other. So this is actually very nice. Some of it it's hard to grasp in the beginning, but after a while it gets really easy. So this was a little bit about management, about Python, HTML, its relationship. But basically, Python can do pretty much anything that any other programming language that you know. If you don't know Python, or if you know other languages, it's basically the same thing. It's arithmetic, variable definition, printing, etc. Let me just do something that I forgot to do before starting the presentation, which was to clean the outputs. No. Is it here? The clean?
Yeah, it was there. No.
Oh, I just want to clean. I don't want to restart it. Okay. What? Sorry. Let's just start. Okay. So, for example, in simple things like arithmetics, definition of a variable, and then some printing, for example, it can be easily achievable on Python, which is the normal output that you expect for some code like this. So, as you have been also seeing from what it was mentioned, and then you see also this interface that you also have it available for you. well, first one thing about Python interpreters and writing Python code. So Python is a general interpreter, so we can write one script file, one script.py file, and you can just use Python to run that script. And Python will interpret it and give you the output of the code that you written. There are also other powerful ways of writing and prototyping code in Python using either interactive interpreters like IPython or Jupyter, which is like a version of IPython, or you can also use other things like Spider and PyCharm, which are integrated development environments, which is more if you're really developing bigger code, I guess that it's better to use those ones. And here we're going to focus a little bit on Jupyter. So you're already seen, because as soon as you start your own, the things that you have available that Matt has given you access to, it's already a Jupyter, well, you already have access to Jupyter notebooks, okay, such as this one. So this presentation is actually a Jupyter notebook, and you can play with it and run the code yourself with what you have. You can do it as, I mean, you can run the cells. So but basically, the notebook is like a graphical interactive environment. So it's like IPython, okay? So and it's made of cells. You have these text cells that like the ones that you see here that you can use formatted markdown text. This is nice to do some reporting. If you want, you can use a Jupyter notebook basically to create a nice report with code in the middle and with titles all nicely formatted and bulleted. You can even put images, whatever you want, and you can interpolate it with these code cells to run the code interactively. So actually, when I was back here, it's basically that. It's basically some text interacted with some code cell. So this is a code cell, okay? Just hit Shift and Enter on it, and it runs the code, okay? Okay, so this is something extra. We talked about it a bit. It's also for us. You can also use it yourself. So in interactive Python, you can also use some magic commands. So that's the link over there. You can also see more about what are magic commands. So this is basically commands that you can run on interactive Python, either on interactive Python or on Jupyter. And you can do, like, for example, things like navigate the file system using commands like ls, or you can even make peers and stuff like that. I think that you're used to do in Bash. And another thing that is also interesting, at least for people that are developing code, is to have some, for example, you want to do some module reload and stuff like that. Actually, I'm going to talk next about modules and what one of the most powerful features of Python, which is the modules. So basically, what is a Python module? Basically, it's a file or many files containing Python definitions and statements. Okay. So basically, when you're scripting or doing something fast on your own for some, I mean, some purpose that you might have, some small scripts or something like that, probably just do some code and keep it locally on where you're doing when you have your data, interact with the data, text files, whatever. But after some time, if you want to get something more, if you're doing that task many times, maybe you want to have a small program that does it and you build a small program. But maybe you can add more in functionality, then you start to build it up, and as soon as this starts to get more hierarchical, you may want to even have a module, which is basically something easy to import, something easy to get. So you get into the Python interface and you say, oh, I have this nice module that does X and Y and Z, and I really want to use it right here for this task that I want to write now. So let me import it. So basically that's it. So in Python, the modules that should be imported in order to use, and I show two ways of importing modules and way of importing a functionality from a module, because you can also do that. Okay? So basically, there's this module called OS, which basically is to interact with operating system and stuff like that. Another module, which I talked about before, which is numpy, which is nice to to do some operations with arrays and stuff like that. So this is an entire module with a lot of tools to do with arrays. Okay, so you can just write lines like this and basically run them, and it will import them. Python will identify this, so you can either import a module, import a module, and use it as a different name. You don't want to call. Imagine that the module is like very long. You can give it a nickname so that you can use it more easily, or you can actually import the functionality. So from a module you import this. Actually, this is unfortunate because this functionality has the same name as the module, so this is a little bit confusing. But this is the name of the module, this is the name of the functionality, okay? So, in the first two, using the functionalities still require the namespace. The namespace is something that you will understand a little bit onwards. Because, for example, this module can have like a function called, I don't know, open, and maybe this module also has a function called open, so then they will get into conflict. So the namespacing is important for that, because then you can use os.open if you want to also use the open functionality of os, or numpy.open if you want to use the open functionality of numpy. Just to give you an example, these things are not even there, okay? Just giving you an example of why it's important, this namespacing, okay? If you're pretty confident on your names, you just want to import the function and not use namespacing, you can import directly. So this is a way of importing, and then the functionality directly. And then you don't need to use glob.glob. You just use glob, and it's already the functionality from this module. Okay. Modules can be a little bit confusing. I don't know. Actually, you can stop me at any time if you have doubts. I just forgot to tell you this, so at any time you can stop me and we can talk about it, whatever are the issues. So, actually, I started to talk a little bit about, for example, the OS module and the glob function. So, it basically it's things that we use a lot to interact with the file system. So, the OS models, as I said before, serves to interact with the operating system. So, I've talked also before that the magic commands can serve to do that, but then when you start to have programs, you no longer use magic commands. Magic commands is something that you want to use if you're using interactively, okay, on the fly, just testing some things. But then if you start to use some, to do a code and a program, you better use this kind of modules. So here I have some examples of things that you can do with this module. That as I said before, the namespacing. Okay, so I was a little bit ahead. So this OS module that we already imported before, don't forget that I already ran that cell. So the OS module has a change chdir function, which basically change directly to this thing. So basically it doesn't do anything because we're already there. So it's just change directly to where we're at anyway. And we also have, for example, another function from the OS. So these are two functions from the same module, okay? List dir. So you list everything, basically the normal ls, okay? So basically this is just the OS module is just some way of interacting with the file system. Normally, that has other functionalities. And for example, the glob is something interesting because it's something that you can also use a lot in your bash terminal and stuff like that, which are regular expressions and stuff like that, so that it can actually return a bunch of path names or a bunch of files that match a given regular expression. So OS does not have that, but we have used glob for that. So here, don't forget, you don't have namespace, it's already imported in a different way. Just call it glob, and we actually list everything that's called Python inside this directory. So basically, there's just this file inside this directory. It's called Python /primer.python notebook. So basically, what this is all of this. So the thing is that these commands are run before, so in order. So first it changed here, but it didn't do anything. It listed dir, but this is interactive Python. So actually, this does not give you any outputs at that point. Actually, this is the output of the last command, okay, of this last command. So if you list this, it should also give this one, okay? So after this introduction on Python and well, notebooks, Jupyter, modules, everyone's following by now. Okay, until now everything's following. Okay. So let's go a little bit into the general stuff, general programming stuff. So Python strings, so strings can be identified by single or double apices. So we have two ways of doing it. For example, new test, a string called new test, okay, and another string called new test. So we can actually define them, okay. You can see there that it has been run. So I didn't explain this. So this is when a cell is run while it's running, it has like an asterisk, and then after it's run, it shows a number. So it's the way that it's presented. So relational operators, you're also familiar with that. So if you want to test some relationship between two variables or between a variable and another thing, so to find the identities to objects, so you can have the normal one. So it's equal, less, and greater, or if they are different, if they can, you can also use and, or, and not, and this kind of operators. So you actually here, what you're going to do, what you expect from here, I think that it's obvious now. You expect this from being true or false. So this is basically we're already defined B and C. So basically we're testing if B equals to C, which basically it's the same because it's just the string is new test. It doesn't really matter the apices because apices is just a definition of a string. So basically it gives an output of true. So this is pretty simple. Just to give an overview, okay? There are more complex things, of course, to do. So in Python, we can also have lists of objects. So we use square brackets to do those. So we can have actually lists of different objects. So we have a list here of integers, so 1, 2, 3, and then we have a string in the middle of that, and then more integers. So yeah, you can define this list, and then you can also print a given element of the list. For example, element number, actually element 3, but I'll give you some more information on that. So actually, the printing the D3, it's going to print the 4th element because Python is a zero-base. Indexes in Python are zero-base, okay? So it starts like 0, 1, 2, 3, 4, 5, 6, 7, 8, okay? This is important also because, well, when you're dealing with arrays and stuff like that, it's important to keep in mind that the indexes start in 0 and not in 1. So here I can do some more stuff if you want. So here we can actually try to print 0 and see that it's actually number 1. And now, actually, I'm going to take the opportunity also to talk about something different that maybe should be here. So we have this thing, and we can actually do operations on stuff, right? So we can even have. So we want to add, for example, the first element plus the second element. If I knew this keyword, no. This. Okay, which is okay, which is fine. But for example, there's one interesting thing is that, for example, let's see if we want to add the first element with the 4th element. So Python will complain about this, and will complain because we're trying to add something that is an integer to a string. So this is one of the most common errors that I see. And basically, if you want to add them, well, you either convert this to an integer, which won't work much well, but you can convert either this to a string. You can actually add strings, which gives you a nice output. Which basically this is converting this element that is coming from here, which is 1, to a string, and then it's just concatenating strings. So a plus on strings is just concatenation, which is kind of nice. So more general programming stuff. So conditional. So if the well-known if clause, right? What else are programs other than if clauses and for loops? So this is a simple one, something just to show the example. So if 1 greater than 0, which is always true, so this returns a true. So this means that we can follow that condition, which means that d equals to 100, and then we just say it. So this is also important to give you some other important information, which is the indentation, that in Python indentation is important. So a way of defining something that is inside other languages can use brackets and other things to define different parts of the clauses, the if clauses, for example. I to start to put the d equals 10 inside some brackets or something like that to define the scope of the if. But here, Python is, this is very important, it defines scope. So after the column that you see there, everything that's inside the scope, it has to be indented. Everything that is outside, for example, the print d, is outside the scope, it's already, so it's unindented, it's already outside the scope. And sometimes you can make, so this is powerful because it's easy to understand, it's easy to do, but it's also very prone to mistakes. So if you mishit some tab or something like that, you can ruin your code or not give the results that you're expecting based on that, okay? So, so yes, please keep in mind that when using so for loops, if clauses, and stuff like that to define the scope, the indentation it's a very important thing to keep in mind. So a for loop, okay. So for I, we have already talked about lists. So I have this list of numbers. So for I in these numbers, let's print it. So print I is inside the scope. Okay. So it will go through the list 1, 2, 3, 4, 5, and will print that list. Another way of doing it is using numpy. And right now this may seem strange for those who don't use numpy, but this is just something that I'll talk later. It's just the introduction for what I'm talking next, which is numpy. So instead of doing that, you can actually do for I in we already defined numpy before. So this is a function of the numpy module, okay, which is called arange, which is basically this 1 to 6. It's basically the same as that thing. Okay, and then I'll explain later the arange also. But this is the same way of writing. Okay, gives exactly the same result. Okay. Any questions until now? No? Okay. I'm either doing very well or very bad. So yeah. Let's introduce numpy because I think that numpy is well, it's central to HTMD. Actually, everything basically that Stefan did on HTMD is basically numpy arrays, going back and forth and manipulating them. Most of the data that we have that we generate on HTMD, it's basically numpy arrays. We load molecules into HTMD. It's basically the coordinates are numpy arrays. We treat the data, all the metrics, all the data that we have. It's everything in numpy arrays. So it's really a powerful tool. It is a powerful tool because it's very, very fast also to do all these operations. If you use some code to go through the things later on your own, it will always be slower most of the time, unless you're a very expert programmer. Okay, so basically, we use a lot numpy arrays. So remember, we already imported the module, so we don't need to import it again. So this is a way, for example, of defining array. So numpy dot array. So this is there's an array function, and then this format of defining this array. Basically, this is defining a matrix, a 4x4 matrix. Okay. and we're storing it on variable m. Okay, so this object, then m is like an object that has this array. So you can actually define it and actually run this cell and and print it. It's nicely formatted there. Okay, so a nice 4x4 matrix. Okay, with double numbers. So here's just one detail. So when we start defining those numbers, notice the little dot after 11. So basically, what is, if there wasn't that dot, it would be a matrix of integers. Okay, but as soon as we have that dot on the 11, every other number, this is already a doubles array. Okay, of double numbers. Okay. So basically that's it. Instead of an integer, you have doubles because of that dot over there. So easy way of defining dots if you want to have more precision. So things that you can do then with these arrays. Arrays can be multiplied easily element by element. So if you had this with this list or something, and then you did your own for loop, it would be like, for each element, for I in this array, let me multiply each element by a number and then make a new array. In NumPy, it's really easy. Just basically you just multiply the object by 3 and it's done. It's quite fast. It's quite easy to understand. You understand basically it's a multiplication of every element by 3. That's it. Which is what is explained there. Scalar multiplication. Okay. So now we go back to the A range that I showed you before. So another way of using NumPy, so we have another function which is called A range, which is nice to create some sequences, which is good for some loops, for creating some loops instead of basing a list of numbers. You just do some nice sequences. For example, so here we are going to do a range that's going to start with 0, and it's going to have, it's not going to stop at 4, it actually has 4 elements, okay? So starts with 0, it has 4, okay? So 0, 1, 2, 3, okay? And with these arrays and sequences and stuff like that, it's also very powerful the way that you can handle them. As I said before, you can handle them in Python. Okay, so for example, this small command here, basically, it says that I want from the first element, it's not the first, remember it's 0 base, so the second element onwards, okay? So of the object O that we just defined before, which was 0, 1, 2, 3, I just want the second element onwards. And it's basically, in some languages it's easier to do, others harder. This is kind of straightforward. So basically outputs an array. So this is actually something, I think this is the first example that we can actually see. Because I didn't show you before. So see how we got the output without printing? Because every time before we were printing. But this is the one feature of interactive Python, and which in Jupyter is interactive. So actually it evaluates the things, and even if you're not printing, it's going to give the output on the fly. It evaluates and gives you the output. Which is nice when you're interactive, when you're doing your own code. You just open an IPython or something, your notebook, and you start playing around. You can just start to evaluate stuff without doing all the screens and stuff like that. It's nice, and you can actually pass things from one to the other, which is also nice. So other operations, okay? For example, I want to define the first column here. So through here, I want to define the first column, which is indexed by 0, to be 99, and then what I want to do in this second command that I'm using here, I'm going to do a backward indexes So backward indexing is also possible using the minus. Basically this means that I wanted less 2 rows. So operation here on this on columns and operation here on rows. Okay. So basically this takes m, which already I defined before, okay? But remember we didn't multiply it by t and put it again in m. So m is still the original one. The n was the one that we defined to multiply by 3. So basically this goes on the first column that we had. The first operation puts everything as 99 and then it cuts off, and you can see that the first numbers that we had 11, 12, 13, 14, okay, 21, 22, 23, 24 have been stripped out. And now you have a new matrix, okay? Just 2 simple commands. It has some syntax, of course, but as soon as you get into the syntax, it's very powerful. We can do many operations very fast with matrices and with arrays, okay? Well, I'm going to show you some more of matrix operations. So you can actually do multiplication of matrices. So you can multiply m by o, okay? And basically it goes like that. So remember that o was 0, 1, 2, 3. So basically it was there 0 multiplied for the first column, 2, okay? It's basically does what we expect it to do. Then you can also do transpose, inner products. So actually, if you go on the numpy module, you can search it. You can put numpy on numpy Python 3 on Google. You can search for the documentation. It has plenty of functions, many things that you can do, and I'm just showcasing some of them. Okay. So, but that's also something important in modules. Most of these modules, and as the HTML is also a module, I also try to do the same, have lots of documentation. So you can go through we try to document it also HTML as much as possible, and those people with these models also try to do it, is to have as much documentation and examples as possible so that people can check out as fast as possible what some functions can do, what are the outputs, what are the inputs, and see what they are doing. And you can actually do it yourself if you want. You can search for that information. You see maybe some of the things, because some of the times, and I've seen this, and I've seen this during my PhDs, that sometimes you're just trying to do things that are already done. So it's easier to search for it, use something that's already open source or someone already made it available for you, and maybe you're learning also. But maybe you're losing 1 week, and instead you could do it in 5 minutes. It depends on what you're doing. But basically, these modules as HTML, it allows you to cut through shortcuts and go faster. Some more numpy operations. So you can concatenate. So we have the O. So 0, 1, 2, 3, 0, 1, 2, 3. Just concatenate. You have two lists. Okay. You can do like so. This basically makes a set over an axis. So basically, this is over x is 0, but you can also do it over x is 1 if you want rows or columns. So you can do it. Actually, if an array is multidimensional, you can go through all dimensions. Okay, not only. I'm thinking 2 dimensions because it's also easier for us to visualize. And, well, we can have other stuff, for example, properties of the null, which you remember it's 0, 1, 2, 3. So it has a shape of 4. This is shape of 4, and then you just have 1. Okay, so otherwise you have other number there, just because it's just a row. But then you have the size of it, which is 4, and then the dimension, which is just 1 dimension. Okay, 1-dimensional array. So now we're done a little bit with the NumPy, okay? Now we're going to do another thing that you can do in many languages, which is functions, which is subroutines that you want to define because you're doing a lot of time, doing them many times, just define a function which is easier. So this is just a test function. You can see here use the def define. So test function, and then you pass some arguments, so A, B, and C. Here you already choose some default arguments for it if you don't pass it anything, okay? And then basically this function just returns the product of A, B, and C. Okay? And actually you have here, so first you have to define the function, otherwise it won't be available. Okay, so if you go right here, the function isn't defined, just complain that name test is not defined. Actually, you should get also familiar with this kind of outputs, which is the trace spec. So every time that there's an error, especially in complex modules, Python gives you the entire trace spec. So you start to have like modules that call functions that call other functions. It has the entire trace spec. It goes back to the original problem. And so to the source of the problem, and then back in the tree, okay, of the code. So here it identifies, since this is just simple code, it's just a problem in the test function, just said that, okay, test is not defined, okay? Basically, it's just because I didn't run this cell, I didn't define it before, okay? So now that I define it, you can see that the result is 5. So on the passing the arguments, the order is important. So you can do here something like 1, 1, 5, and it will be exactly the same result, okay? But here, for example, I don't want to define B. So this second element, it's not B because I'm telling that this is C, okay? So, and here B is defined, so it takes the default one. This one is replacing that default one, and this one is by order the A, okay? So then it does a multiplication. 1 times 1 times 5 equals to 5, okay? Again, no print, interactive, automatically evaluating the output and giving you the output, okay? So let me just check the time. We have a coffee break now after this, right? Or no?
Yeah.
Yeah. Variables and objects. So Python represents all its data in objects, okay? Variables are just names, and some objects are mutable, some are immutable. So immutable objects are integers, floats, complex numbers, strings, stuff like that. And then we have mutables like lists and arrays and dictionaries and classes. And this is an important feature to take into account. Especially when passing the arguments and stuff like that, and I already made mistakes in that. Stefan can testify that, and sometimes this can get a little bit ugly if you're not careful enough. So, giving you an example. So actually, you can actually use this function, which is ID, to see the identity of an object to see if it's a new one or not. For example, we define here n as it's an immutable integer, okay? And then this is an interesting thing of Python. This is immutable object. So we do this operation on n, and this is like n is destroyed, and there's a new n created, which is a result of that. This is not so common in other languages, but this is how Python works. Some people complain, others know. So you can see here that the identity of n, which is this string over here, is differs from that one, okay? So when you do this operation, it actually destroys one n and creates a new n with the result of that, which is actually, in this case, would be 2, okay? And this is the case of immutable objects, okay? In the case of mutable objects, you can see here, okay, we have basically a list of one element, which is 1. It's a mutable list. And you can see here that, so exactly the same procedure. So it has a given ID, but then I do an operation, and you can do this command is an append. So you do an append on the list. Basically, you append this element to the list, so it's going to be 1, 2. But since it's a mutable object, it will still be the same object, okay? It has exactly the same number. So This is an important feature for to take into account, because some programs may fail or not, or work or fail depending on that. Okay. Also, because of this that I was wanting to talk about, so argument passing. So passing an argument to a function is like creating a new name to the object. Okay. If it's mutable, then any change inside the function will affect the object outside. Okay. If it's immutable and the function changes it, it just happens inside the function. So this is an important thing to keep about. If you're passing integers or lists or arrays or strings to a function and you are expecting some results or others, it really depends on these properties of these objects. Okay. This is a somewhat of a detail, but sometimes it plays along, especially when you're trying to debug your code and stuff like that. Okay. Just here is basically a function that's quite an overview of many things that we did. So here we go to this. So there's a plotting module which is called matplotlib. So you can just go there and from there import some functionalities. And then, for example, you can have this magic code, which basically means that you're going to plot in line with the Jupyter notebook. So this is a magic command for the plot to be here inside the Jupyter notebook to see the output. Then you just use numpy here for some variable definition. Okay, so use a range here, just create a range between 0 and 50 with an interval of 0.5. Then we create another function with the sin function and the cosine function, sine and cosine function of numpy. And then we just want to plot x and y using dots and lines in black. And then you want also to plot another function in dots in red. And then define a title, label, and stuff like that. So these nice things. I don't know which each person has a favorite plotting, and then you show just a plotting program. And well, this seems quite nice. I mean, there are plenty of modules available for plotting. You can still use your own program if you want, but I think that as soon as you start to get into the Python environment, you get everything integrated. It's nice to have all the functionality integrated inside one thing. That's also the power of HTMD, of Python, and of HTMD as a module of Python, as you can also not only have all functionalities of HTMD, you can also integrate it with other Python models that you may be interested in, and gives you a lot of power just in one script, in one thing, to do a lot of things. So basically, it did what was defined up there. So, okay, 0 to 50, it's two functions, one in black and red and stuff like that. Okay. Well, you can also save the plot, okay, which is okay. Okay. Yeah. So more things. So this is almost to the end. So more things that are important also for you when you're starting with Python and starting with this is that how to get help. Okay, how do I know the modules? How do I know the functions? What are these? So you can actually have. So for example, you used to use the help function to do something. Okay, like this. Just prints the documentation that this, for example, the print function adds. You can use something different if you want. If you're in a Python, in a Jupyter notebook, which is, for example, you're doing OS change dir. Okay, you can do this nice thing, which is so use the tab. Okay, to start to do the complex session of things that you have available in the module. So I want to do OS dot, and then I hit tab, and I get an array of things that I have available here. Okay, some of things are properties, others are functions, some of things I don't care about. For example, I want change dir again. Okay, and then I don't know what it does. Okay, so what I do and what I did right there is the shift tab. Okay, I'm going to close it and do it again. Okay, so you have it here, something like this, and now you do shift tab. Okay, and now it basically shows the documentation, which is kind of small, but it may be useful. And then you can actually open it and see what it does. So normally, this is how things are documented through dot strings. So it has some information on what it does. So basically, it says what it does. Change the current working directory to the specified path. And the path is the argument. Remember, I used before the string with the dot, which means just moving from the current working directory to the current working directory. But, well, you can put anything. So this is kind of helpful, this using the help, using the Jupyter notebook with this function. I think it's nice for people that are starting to get to know the functions, okay? Last thing, debugging codes in notebooks. So you can use this magic. You can use this magic command, which is called debug, so with a percentage. So I have this broken function that we wrote over here, so broken function. You can already see what it's broken. I think it's fairly obvious, because I already showed you an example before. But basically, it's going to fail. And as I said, at trace back, it goes back, so it fails here. And then what it fails, it goes back, it goes to the function that is failing, which is broken function, and points where is it failing. So one of the things that it's also powerful, this is very easy, but because this is a simple function that you can actually debug. What this allows is that when you're inside a complex program, you can print. So, for example, if variables change a lot during that program, you can actually go to this spot and print variables, go up and down the tree of the hierarchy of the program, and see how variables are defined in one or the other. So, for example, I can print here B, says that it's 4, okay, and so on and so forth. I can use some magic, some commands like up to go up the tree. So I was inside. See here the arrow. I was inside the broken function. Now I've moved out of it. Go up a little bit. Okay. On the tree of the hierarchy of the program, so you can actually here test other things like C and stuff like that. So it's an interesting tool that you may find it useful also on this helping kind of thing. So this is the last slide. So basically, I would advise you to, which is something very important, visit the Python website, which is there. Visit documentations, which is very important. I mean, it's not. I think that with experience, one learns things, but we need really to also look into the documentation and how things work. For the HTML package, which are going to talk after start talking after the coffee break, we can also visit the documentation. We also have it available through the same kind of interface. So we can go here on H. So if you don't know our website, you probably do, www.hmd.org. Inside that, you already can click documentation and go directly here, or just use this command, this web link. Okay, fine. Are you doing it to the stuff? It's done. Okay. Good. So yes, we are good for now. We're going for a little coffee break, no? And then we'll be back in, I don't know how many minutes of the coffee break. So. Okay.